Hello guys, welcome to another Python machine learning tutorial. In this video tutorial, we're going to discuss about pipeline. So let's get straight into it. So this is the flow chart of how the entire pipeline is like. Let's say you're developing a machine learning model for to solve some problem. So there is this procedure like best practices to follow so that you could get an optimum output. So that's what we're going to discuss here. So it all starts like this. You have your entire data that you want to like analyze. Do machine learning on, and then so before you do that, you're going to split the data into training data set and the test data set. So you use the train data set to like train your algorithm, and then you'll use your test data set to test how effective your algorithm is. The model that you have developed. So, what's the best procedure to follow so that you get the optimum output? So that's what this diagram depicts. So you have your training data set. You split your entire data set into like training data set and test data set. So in training data set, you have the class labels. Identity class labels. Right? So yeah, let's say you want to predict something. What you want to predict. If you want to predict the outcome X, then that X is the label. If you want to predict the outcome Y, then Y is the label. So in your training data set, you have the label. So you design a model which is like this. The scaling, in the first step, scaling, you actually like scaling your data. So you're actually standardizing or normalizing it. So that's what the scaling is all about. And then dimensionality reduction. So what's dimensionality reduction? Let's say you have, let's keep it like this. You have speed, velocity, and distance. Speed, speed and velocity are same. Sorry, speed, distance, and velocity, and then the name of the car. So obviously, if you have uh, speed, if you have speed, sorry, time and distance. Okay, let's keep like this. You have time, distance, speed, and name of the car. So if you have time and distance, you obviously can calculate the speed. So you have two redundant data, time and distance. You could simply use speed to like estimate or brand the car. So those two are like redundant features. So you can get rid of that so that you make processing easier. Everything is easier. So that's what's called dimensional reduction. So removing unwanted features from your data set. And then here comes the learning algorithm. So you could choose any learning algorithm you want. Support vector machine. You could use logistic regression. You could use whatever learning algorithm that you want that you could use. And then you predict it. No, predictive model. Sorry. And then as a result of the learning algorithm, you're actually predicting it. So that's the pipeline. That's a good procedure. Pipeline to follow to get the optimum output out of your machine learning algorithm. So we could actually do that and do this in Python, and that's what we're going to see. So if you open this one, I actually wrote this is my as usual. I'm going to like copy paste the code and explaining each and every single step. So what we are doing in this tutorial set is like we are importing data set, breast cancer data set from Wisconsin, Wisconsin database. If I'm not wrong, I don't know whether I have it open. So I have it here. So this is actually the data set. So we're actually importing the data from here. Put an icon and press enter and it has to open for you. So we're actually opening this database. So this is the data and it has 32 features and somewhere around 400 rows of data. Okay. So we are gonna like it's actually a data about a tumor being benign or malignant. So that's what it is. If you see here, this is M, and B is benign, and M is malignant. Okay, so we're going to classify the tumor by training the algorithm with these data set. Okay, that's what we're going to do. So as usual, let's start copy pasting it. So and then I mean, once we get the data from the Wisconsin database, so we're going to follow this procedure, and then we're going to estimate the accuracy of the model. So we'll be doing scaling, we'll be doing dimensional reduction. There, like scaling, you could do by normalization or standardization. Okay, dimensional reduction, you have few techniques in dimensional reduction. So yeah, you could play around with those techniques so that you could choose the one that's optimum for you. And learning algorithms, as I've told you, like a variety. So we follow this pipeline, and then we're gonna like get the accuracy output and see how accurate this model is. So that's what we're gonna do. So let's start copy pasting. Okay, let me bring in like everything. No, it's better if I go step by step. Copy this. So like that. So we need pandas. So we are bringing in pandas first. Okay. So and then we are taking the data from the internet. So this is the code for that one. Copy this. Paste. So you can actually print the data now. Print df save and fr. Not this one. So yeah, this is the data. So if you want to know like actual size of this data frame, so you could print here as 32 rows, 32 columns, 32 columns and 569 data in different rows. So now we are gonna like process this data. So first and foremost technique, you have to split the data. You have to split the data into like training data and test data. Okay, so let's do that. Copy, paste. Okay, so this line of code, what it does. So yeah, if you look at this data set, let's go all the way to the top. First one is some number, we don't care. And this is actually the label. So this is the one that classifies the entire data, whether it's benign or malignant. So this one will be a Y. So it is actually second column, the second data in the row, you know, or second data in the column. Where the heck is? Okay, so that's what we are doing. So Y, this means entire row. If you don't specify anything, it will take the entire rows. From that, it's going to take first column. So it starts from 0. This is 0 and this is 1. So and then from there it takes values. So x is going to be from here. Everything else is going to be the x. So that's what this line of code does. So all the rows and from to all the columns. So now we have got your action y. So let's see, like you want to see that. So let's go ahead and print y first. So here you go. It's all your y data. And print x. So your x data. So it's all truncated data. That's why it looks quite small. Pandas always truncate so that if the data set is huge, then you can actually make any sense out of it by seeing it. That's why I truncated for you. So So you have it here 1, 2, 3, and it's all concurrent and couple. Okay, but it's actually the total data set size is this. Let's minimize this and bring in the next one. Now we are going to use a label encoder so that we could convert labels, m and b into numerical values, 0 and 1. So let's bring in the library first. Copy, paste, and then declare that imported label encoder on a variable so that you could actually start using it. If not, then you could just like that type label encoder and then start using it. It's make no difference, but it's going to save a lot of time by using a two-letter word as a replacement for the word label encoder. Okay. So now we are gonna like fit and transform only y because you want because it's the only categorical data. So you grab y and then you do fit and transform. So y is gonna be again le dot fit. We are using fit and transform method to like convert them into a numerical value. So now you can actually print it out so that you get to see. Wait for some time. It takes some time for processing. Yeah. So now it's all converted into 1 and zeros. So you can actually see both of them. Print y, which is gonna be categorical value, and this y is gonna be a numerical value. F5. So yam is malignant, which is 1. The other one b is benign. Okay. Now you converted them into you get rid of this one, so you don't have to put anymore. For as of now. Now you converted them into like categorical numerical data. So it's actually so you could actually start creating a pipeline now. Okay. So now you have your data ready. So we have to import pipeline from SKlearn pipeline. So it's all available in SKlearn. I'll go there. From SKlearn the pipeline import pipeline. And then you have to declare it on something. So we declare it on pip.lr, which is a so-called abbreviation of you could call it anything that you want that we don't care, but I'm calling it LR. Is the reason why I use LR is because I'm gonna use LR machine learning algorithm. So for that, okay. So now we have imported pipeline. So what are all things that we need further to like play with the pipeline? So you need scaling. You need functions to do scaling. You have to import the scalar thing from the pre-processing. So that's what this one is. So you import the scalar. Okay. After that, okay, I'm gonna minimize this. I might get into a copyright issue. I'm just spreading this information. Okay. So for dimensionality reduction, you have to bring in this. I know what is a PCA. This is one of the techniques in reducing the dimensionality. They call this regularization. I'm not sure, but they call it something regularization to reduce the dimensionality. This is for dimensionality reduction. Dimensionality reduction, and then the next one is the learning algorithm, which will be using logistic regression. So we actually haven't split our data yet, so we have to do the splitting of data into training and testing. So for that we need train, test, split. So first let's split our data. So here is our data. So this is the line of code that does the splitting of data into training and testing. So it has to go over here first. Yeah, this is the right place to put, because first we have to split them into x and y and then convert them into numerical data and then split them. Now you have everything, if I'm not wrong. So 7. We haven't bring in. We have bought in pipeline. Okay. So I'll explain you guys like what this line of code does. This is actually the pipeline. Okay. So let's get to understand that better by like putting this thing next to this so that we get a better understanding of what's actually happening. So we have to do scaling. So for that we brought in Scala, imported Scala from pre-processing, and then you have to pass it as an argument to a pipeline function. So you pass them in. Then for dimensional reduction we are using PCA. So you're actually reducing 32 features into only 2 features, and yeah, so you're actually like reducing data set size by a large amount. So that's what this and you're using PCA technique for that one. Okay, and the argument n underscore component equal to 2 means that you want to reduce that to 2. So and then the regression that we are using, I mean the algorithm, the learning algorithm is logistic regression. So that's what logistic. That's what I mean. This line of code does. Okay. Now I think we are pretty much done. So we could go ahead and write the code to like check the accuracy. So before that, you fit the data. So it will calculate all the weight parameters. Once the fit method is done, and then you could go ahead and use the score method, like to get the accuracy. Yeah, we want to print that out, so we use that next to the print statement. So your algorithm is 94% accurate, 94.7% accurate. So let's say we increase this to 30. We actually have 32 there. No, that's including label. We also have see, the accuracy has gone up. But you can't put 31 because you only have 30 features. It has to show me some error. I'm expecting an error out of bound. Array out of bound, yeah. So because you actually have 30 features. The first one we are ignoring, I don't know for what reason. The second one is a column and the rest are the label. So when you use the entire label, I mean entire features, not label, your accuracy is 98%. But you want to reduce the processing time and you want to reduce the time. So you want to choose only 2. Okay, so you are giving 2 as an argument, and your accuracy has come down to 94.7%. So that's the effect. If you're okay with 94.7% accuracy, then you're fine to stick to this one. If not, you play with this and then you figure out which is the one that's suitable for you. Um, so why do we do all these things? The scaling thing we do for reducing the overfitting and underfitting. So we want to be a uniform fit. If generalization has to occur, I'm not sure whether you guys can understand what these things mean. So what's an overfit or what's an underfit? Let's say you have a data set. So the decision boundary that your algorithm going to draw for your training data set is going to be around your training data set. And if it is an overfit, or let's say it's an underfit. So if there are any other, I mean, similar data set with the same label, we give to that algorithm for prediction. It's going to like predict it as a false. It doesn't belong to this data set, even though it does. So that's called underfit. And overfit is like just opposite of that one. So in order to like get rid of all those problems, use this pipeline so that we get a proper optimum output. So that's what this tutorial is all about. So in this tutorial, you get to know about the pipeline, and in that pipeline, you could do like normalization or standardization. You could do the dimensionality reduction, and you could choose the algorithm of your choice. And you have different techniques for reducing dimensionality. Like you could check out the documentation from that, like know about it, and then you could predict it and you could test your accuracy score. So that's what we have discussed in this tutorial. If you guys have any doubts in these topics, then comment below. If not, like the video, subscribe, share. Thanks for watching. Bye for now. See you guys on the next video.